Hey everybody, I just wanted to send this memo to talk about our human. I've noticed she hasn't been getting out of bed as easily anymore. She seems to be nervous all the time, even about things that might not happen, and her chest is hurting a little when she gets overwhelmed, which is a lot more than she used to. I'm trying to help, but I feel like there isn't enough of me to go around. I'm supposed to regulate her mood, sleep, and behavior, but it's just so much. I talked to my brain the other day too, and she feels like she can't produce enough of us. I know I shouldn't feel bad. Over 40 million people in the United States go through anxiety, and 11 million go through depression. But these numbers are rising so much due to the COVID-19 virus, and I want to make sure she's still able to go to school and work. I wanted to see if you guys are being affected at all, or we're producing enough. I'm usually so bright and cheery, I just wanted to see if there was anything we could do.
Oh no, I knew something was wrong. I know we can make her stressed, and that makes me stressed. Her brain hasn't been producing enough of us serotonin, and there's no one stopping us from going through reuptake, so there's just not enough of us to go around in the synaptic gap. And I thought I was getting lazy. I can tell I'm overworked because she's kind of spacey, and it's my job to keep her energized. No wonder she wants to sleep all the time. We're neurotransmitters. This is supposed to be what we do. We're supposed to keep ourselves in check, but how can we when the brain isn't producing enough of us? The neurons have been getting mad at us that we haven't been sending enough messages, serotonin. I think our levels might be the problem.
I'm the transport protein, and I think I know how to help. I know somebody who deals with these types of things. I can try to describe to you what happens, as I've done this a couple times before. So, you know the little gap between the neurons where you guys send your messages? That's called a synaptic cleft. There's this little thing I do called reuptake, right? Basically, in really simple terms, I take some of your neurotransmitters back in to start the process again. With depression, there is low levels of transmission of serotonin, norepinephrine, and dopamine between our humans' neurons. However, if we can get somebody who can inhibit the reuptake of you guys in between the neurons, more of you will be transmitted and your human will feel better. This person can inhibit only certain kinds of transporters, though. I can be a little selective with what I transport too, but as a sodium dependent noradrenaline transporter, I transport norepinephrine using sodium ions utilizing a sodium gradient. Protein transporters like me are called biogenic amine transporters, and we can translocate serotonin, norepinephrine, and dopamine back into the nerve terminal and remove them from the extracellular space. I usually get 5-hydroxytryptamine into nerve cells with sodium and chlorine ions, and I kick out a potassium ion while I'm in there. Blocking reuptake will be key to a solution, and I can pass on the message to my friend who is great at blocking transporters like me from reuptake and see how she could help our human out. She explains things a little more technically than I can. I just take whatever she needs me to.
Hey, I'm duloxetine, and I think I could have the solution to your friend's problems. I'm the perfect antidepressant for the job. I work by targeting the area between neurons called the synaptic cleft. This is the area where communication between neurons occurs, and this communication happens via electrical signals that turn into chemical signals through the release of neurotransmitters. The neurotransmitters are released where they can go through reuptake in the synaptic cleft through the transporter. Reuptake is what prevents the neurotransmitters coming from one neuron to be received by another, since the neurotransmitters are instead going back into the presynaptic neuron once again. Your friend has less transmission of neurotransmitters like serotonin and norepinephrine with depression. The transporter doing reuptake is making it so that even less of the neurotransmitters are found in the synaptic cleft, but I'm an SNRI who can keep up the levels of both neurotransmitters. SNRIs are serotonin norepinephrine reuptake inhibitors, which block the transporters that communicate the release and reuptake of neurotransmitters serotonin and norepinephrine. I can selectively inhibit serotonin norepinephrine transporters via transporter complexes on the presynaptic membrane. I'll stop the reuptake by blocking serotonin and norepinephrine from going back into the neurons that release them. This will increase the concentration of serotonin and norepinephrine that's found in the synaptic cleft and the potentiation of activation of postsynaptic receptors, since these neurotransmitters are no longer going back into the presynaptic neuron. Since depression is associated with low levels of the neurotransmitters, and I've created normal levels once again, some or all of the patient's depression will be temporarily cured. Serotonin and norepinephrine are recognized as the main neurotransmitters involved in regulating pain mechanisms as well, so this can relieve the chronic pain associated with depression. When you compare my structure to the structure of serotonin and norepinephrine, you can see that we look a lot alike. This is what allows me to be a competitive inhibitor for both serotonin and norepinephrine transporters, like the sodium-dependent noradrenaline transporter. My structure contains an oxygen, which is a hydrogen bond acceptor, and an NH group, which functions as a hydrogen bond donor. The nitrogen in this functions as a hydrogen bond acceptor as well. This makes me great at hydrogen bonding. And see that aromatic structure with a sulfur in it? I can do pi-pi interactions with my aromatic rings. Hydrogen bonding is a weak bond between two molecules resulting from electrostatic attraction between a hydrogen in one molecule and an electronegative atom in another. Pi-pi interactions include pi stacking and pi cation interactions. Pi stacking is the attraction between aromatic rings due to their pi bonds through a combination of dispersion and dipole-induced dipole interactions. Pi cation interactions are stabilizing interactions of a cation with a polarizable pi electron cloud of an aromatic ring. I have many non-covalent interactions with the transporter protein, including the hydrogen bonding and pi-pi interactions I just described. I have hydrophobic and van der Waals interactions with alanine 105, proline 101, valine 104, valine 261, tyrosine 21, and tyrosine 108. That molecule in the middle is me, and the green ribbons are the transporter protein. First, this is an example of my pi stacking interaction with one of my aromatic rings in phenylalanine 253. Next, this is an example of my pi cation interaction with my amine and tyrosine 21. And finally, this is an example of my hydrogen bonding interaction with the amine and tyrosine 21.